Hey guys, let's read the question that we have here today. Consider a ket space spanned by the eigenkets A prime ket of a Hermitian operator A, and there is no degeneracy, so we have to prove that pi of A prime, A minus A prime, is a null operator. That's the first part of the question. Second part of the question, we have to find that what is the significance of this operator, pi of A prime unequal to A prime, A double prime unequal to A prime, A minus A double prime by A prime minus A double prime. And thirdly, we have to illustrate that A and B using A set equal to Sz of a spin half system, Sz operator. So it's the spin operator in the z direction. Alright, so let's start. Let's see what we have in the first question. I just read it. Alright, so let's start. So in the first question, we have been given that pi of A prime, A minus A prime. You have to prove that it's a null operator. Alright. So the ket space that we have been given here, that is A prime ket, let's just write it like a set of basis kets AI, where I goes from I to some n. Let's consider it some n-dimensional ket space. Alright. So if it's an n-dimensional ket space and A is a Hermitian operator and AI are its eigenkets, so if we operate A with AI, we should get some eigenvalue AI and the ket AI back. So we'll use this and let's consider a general state which is made up of these basis states. Let's change the index. Let's take j as the index, and we'll say that some cj and aj. So psi is just some state which is comprised of the basis states aj. Alright, so now let's try operating the given operator with psi. So pi of ai, because I have changed the index over here, so I will be using AI here. Pi of AI, A minus AI operated on the state psi. So what do we get? So here A is the operator, so it will act on psi, and AI is just a value. But first let's just put the value of psi over here, the state psi. So we have pi of AI, A minus AI, sum over j cj aj. Alright, so further let's take the summation j outside, and cj is just a number, so let's take that outside too. Then we'll have pi of ai, a operator minus ai, and the ket aj. So this a will act on this state aj, because and since it's a eigenket of a, we'll get the value aj back. So we'll have summation over j cj pi summation over I. I'm sorry, this would be a summation over I over here. I messed up the index over here a bit. Same over here. So this would be a sum over product over I. So cj pi I, and we'll have aj minus ai times aj ket. Alright, so let's try evaluating the products pi I, aj minus ai. Let's find what this value is. So pi I, aj minus ai, and let's also consider the sum over j cj. Let's just remember that there is a sum over here. There's a sum over j. Let's evaluate this for now. So if I open this, we'll get aj minus a1, aj minus a2, aj minus a3, and so on. Now there is a sum over j and a cj. So the sum over j would also go from 1 to 2 to 3. So when we are considering j is equal to 1, this term will go to 0. When we'll have the sum for the second term, where we'll have j is equal to 2, this term will go to 0. And so on and so forth, all the terms would go to 0. So the value of this whole term is just 0. So we can write that this operator pi of I, a minus a of I, psi, cat psi is just 0, which we can further write as 0 times the cat psi. So we can see that this here acts as a null operator. So we have the proof to our first question. Now if we try to solve the second question, we have to find the significance of this operator given to us. So in the second question, we have to find the significance of pi a double prime unequal to a prime a minus a double prime by a prime minus a double prime. You have to find the significance of this operator. So I'll be changing the index over here again. So we'll take some j is unequal to I product a minus aj by ai minus aj, and again we'll consider some state psi, which is comprised of the basis states. We'll call them AKs. Alright, so let's try operating this psi on the given operator. So we get pi of j is unequal to I a minus aj by ai minus aj times psi. So again we'll put this value over here. So pi of j is unequal to I a minus aj by ai minus aj sum over k ck ak. Now again, if this operator a acts on ak, we'll get the value ak. So we'll have j unequal to I ak minus aj by ai minus aj, and there's a ck over here and there's a sum over k over here. Alright, so oh yeah, I also forgot the cat ak. So let's evaluate this part, which is just j unequal to I ak minus aj by ai minus aj. We'll take care of the ck and the cat ak later. Let's just find out what this value is. So if you like look at closely, it's just the Kronecker delta function of I and k. I'll prove it how. So what I'm claiming here is that pi of j unequal to I ak minus aj ai minus aj is the Kronecker delta of I and k, such that it is 1 when I is equal to k and 0 when I is not equal to k, right? Alright, so the first one is pretty clear. If I set I is equal to k, so this term here will become ai, and if this term here becomes ai, then ai minus aj and ai minus aj, all the terms would cancel and give you 1. So the first one is pretty straightforward. Let's try proving for the second one. For the second one, let's consider a case. So let's consider for k is unequal to I. Let's say that for k is equal to 1 and I is equal to 3, we'll have these values. So a1 minus a1 by a3 minus a1, and since j should be unequal to I, so we have to, like, we cannot consider the value j is equal to 3, so we'll only go up to a2, so it will be a3 minus a2, because if we take j3 is equal to 3, so it will be a3 minus a3 and we'll get a 0 in the denominator, so we won't consider that. And in the numerator we'll get a1 minus a2. So as you can see, this term would go to 0. And similarly, if you consider more cases of k and I, you can check by hand, all of them would go to 0 in cases where I won't be equal to k. So this will always give you 0. So this here is just a Kronecker delta. So now if we further evaluate our previous, we got this. If we set this pi of j unequal to I, ak minus aj by ai minus aj as Kronecker delta of ik, we'll get summation of k ck and Kronecker delta of ki and ak. This is what we get. Now if we take k is equal to I, because at k is equal to I, this will give us the Kronecker delta would be 1, and if k is just unequal to I, this whole term would go to 0. So let's consider this case where k is equal to I and this becomes 1, so we get sigma I ci and ai. We get this. Now again, we know that we have previously considered that psi was sum over k ck by ak. So let's change the index over here. So we'll have summation over I ci ai. Now in order to find the value of ci, we'll use Fourier's trick. We'll multiply both sides with the bra ai. So we'll have ai psi is equal to ci. We'll put this value over here. So what do we get? So we get ai psi ai. Oops, it will be the ket ai. Now this is just a number because it's the inner product, so we can shift it to this side. So we'll get ai and psi. So if you recognize this is the projection operator lambda I. If you don't know this, the projection operator of some basis I is given by ai, the ket of ai times the bra of ai. So this here is just the projection operator acting on psi. So we can write it as projection operator I times psi. So what we initially began with was this here. If we see, it's nothing but the projection operator acting on psi. So this operator here is just the projection operator for the ith ket or the ith basis. Alright, so now in the last question that we have to solve for, have to illustrate A and B using A set equal to SZ spin-off system. Okay, so let's consider SZ operator as A, and since it's a spin half system, we'll have these two bases, that is plus and minus. So there are only two bases here because it's a spin half system. So now we know that the SZ operator can be written as h bar by 2 bra plus cat of plus, actually the opposite, or you know what, let's not do it this way, let's use matrix representation, that would be easier. So SZ we can write as h bar by 2 1 0 0 minus 1, right? So now this operator AI A minus AI would be just SZ minus h bar by 2 and SZ plus h bar by 2, right? Now okay, let me be clear here, I think I confused you over here. So since there are only two bases, the space that we had AI just has these two cats as their eigencats. So we have plus and minus, and you know the eigenvalue for plus is plus h bar by 2, and the eigenvalue for this minus cat is just minus h bar by 2, right? So AI is just the eigenvalue for the first one, that is the plus. So I have written here this is a plus h bar by 2, and this here was a minus h bar by 2, so the minus minus cancelled and it became a plus. So that's how we wrote the representation over here. I hope it's clear. So h bar by 2. So since it's a 2 cross 2 matrix, SZ is a 2 cross 2 matrix, so there would be an identity matrix here, that would be a 2 cross 2 matrix also to satisfy the algebra. So now if we calculate, we'll have h bar by 2 1 0 0 minus 1 and minus h bar by 2 1 0 0 1. That's for the first bracket, and for the second bracket we have h bar by 2 1 0 0 minus 1 and plus h bar by 2 1 0 0 1, right? So this will give us h bar by 2 0 no not 0 0 0 and minus 2, I think, right? Yeah, and here we'll get h bar by 2 2 0 0 and 0. All right, so we'll have h bar square by 4 0 0 0 minus 2 2 0 0 0. Now if we multiply these two, let's see what we get. We should get a 0 matrix, so this will be 2 this will be 0, this will be 0 as well, 0 times 2, and this will be 0 as well, and this will be 0 as well. So yeah, we get a 0 matrix, which is the null operator. So yeah, this does hold for the SZ system for the first operator. Now let's check for the second one. So the projection operator for the spin half, projection operator for spin half would be there would be just two operators, right? One would be plus and one would be minus. So for plus it would be ket plus bra plus, and for minus it would be ket minus bra minus, right? So if we consider plus to be 1 0 and minus to be 0 1, the projection plus operator would be a matrix of it would be a matrix of 1 0 and 1 0. So if we multiply this, we'll get 1 0 0 0. Similarly, the minus we'll get 0 1 and 0 1. We'll get 0 0 0 1, right? So I'll just prove it for the first one. You can check for the second one. So we had been given that the operator pi j unequal to I a minus aj by ai minus aj. Now since there are only two bases, that is plus and minus, so if I said I is equal to plus and j is equal to minus, so we are claiming that this is pi of I, right? Lambda of I, right? So if we put I is equal to plus and j is equal to minus, we know their corresponding eigenvalues, so we'll get the following. We get pi of j unequal to I as z, a minus would become minus h bar by 2, so this will be plus h bar by 2. This would become plus h bar by 2 again, and this would be minus times minus plus h bar by 2. So we get 1 by h bar as z plus h bar by 2. So let's calculate what value we'll get for sz plus h bar by 2. So this would be h bar by 2, 1 0 0 minus 1 plus h bar by 2, 1 0 0 1. So here we'll get h bar by 2 plus h bar by 2, so that would become h bar 0 0 and 0, right? And we also have this here, so there will be a 1 by h bar common over here. We can take h bar common from here, so we'll have h bar 1 0 0 0 times 1 by h bar, and these two would cancel out, so we'll have the matrix 1 0 0 0, which is just the projection operator in the positive direction. You can check for the projection operator in the negative direction. That's homework for you. Yeah, so that's all with this question. That was all with this question. See you in the next video.